Hi everyone, my name is Konstantin Belov and I am performance engineer at Linaro. And today's talk I'm going to describe our attempt to build a continuous performance evaluation system for Linux on ARM64. And the first question, why do we need this? I think it's obvious, but we need to highlight that continuous performance evaluation it's improving for the last 5 years, but it's not at the same level of quality and visibility as Intel has. We would like to detect and prevent performance regressions across diverse ARM64 hardware, and we would like to help kernel developers and vendors to find the root cause of performance issues faster. And the current state of this topic is the following. So it's improving. We have several projects which aim in the same goal to find regressions and evaluate performance, but they're still not as good as for Intel platforms. Huge variance and hardware diversity remain challenges, and we don't have centralized and automated regressions as 0-day for Intel has, and the other issues which we listed here. So limited visibility of performance issues, one of the reasons why we're doing this. And we would like to have a public dashboard which will show you the current state of the kernel and its performance on various hardware configurations and platforms. So to improve the situation, one of our clients asked us to do that. That's our attempt and story how we are doing this. So when you have such task to implement something like a 0-day project, it's obvious to take their code and adapt for your needs. But unfortunately, if it's a good system, but unfortunately it's not easy to adapt for ARM. It's Intel focused, and you need to spend a lot of time to write a lot of things inside of this. The next obvious candidate for such foundation, this such system, it's Phoronix test suite. It's quite well known and quite popular, but it's more general purpose. It does a lot of testing. They report a lot of interesting regressions, but it's a huge system, and it has high adoption overhead and very complex setup. So it's so feature rich and big. So I thought that we need something less big, and I chose tests. It's a small framework, and at first glance, you can, when you see on its source code, you can think that it's almost a mirror like for LKP, but it's not. It has similar architecture, but clearer documentation, more clear methodology, and it's more CI friendly. It also has its own set of features which is highly useful for building such system which will evaluate performance. And the last candidate was Reframe for this job. But Reframe, it's a regression testing framework for HPC environments. And it has a lot of features, very flexible, but it's very complex configuration, and you need to customize it heavily for ARM. Plus, it has very high entry level. So I stopped on tests, which all these systems, they provide the same set of features, so they can prepare the environment, build benchmarks, deploy it, run benchmarks, collect the results, parse the results, somehow analyze them, compare to previous set of results, and give you an answer, do we have regression or not, or show you some numbers and so on. But they're doing this in very different ways. So we need something simple enough to customize. And MMTest suits very well for this purpose. And yeah, so we have system. We have build system for kernel with tax build, and we have pipeline for that, but some challenges remain. Benchmarking is time intensive, so it can take hours or days to get a full cycle of testing, and you need somehow to parallelize jobs to make it faster. There is no single standard benchmark suite. Unfortunately, you have to use multiple of benchmarks, and they all have their own specifics in the target areas of the kernel. So sometimes they overlap, sometimes not. Lack of, well, limited availability of target devices. Some hardware, high-end hardware is very expensive, or you just cannot get it, like Graviton 3 or 4. You need to rent it. Devices and SOC fragmentations, so a lot of vendor-specific tweaks, customizations, and so on. So it just make results analysis harder. Kernel configuration options also, it's infinite options how you can configure and build a kernel. It also makes the analysis high, well, very, very, very hard. But so it's not the end. Scaling fairness for this performance and efficiency cores also brings some challenges. It depends on the it affects how you treat detected regression. Is it true regression or is it not true regression? Is it worth to spend time on this or not? And so on. So noisy neighbors, thermal throttling, power management, this all brings noise to results and complicates the analysis. Also, reproducing results, one of the critical things. So we cannot report performance regression if we cannot reproduce it for 100% sure. And so we need to make it reproducible, easily reproducible, without complicated setups and execution. And the last, it's not the last, of course, but here it's the last. The broad audience of people interested in this type of testing, and each group of people interested in different use cases, and this also complicates the interpretation of results in the analysis. So it's really hard to create universal reporting system which will be suitable for everyone. So for server guys, it's one angle of view. For mobile devices and mobile guys, it's a different angle. So, so this is one of the hardest, I suppose. So our attempt to build such system, it's not the first time, but this time it's well, more or less successful. It can produce and detect regressions and improvements. So it contains multiple components, but core components that already discussed here. It's tax trigger, tax suite, and all these tax utilities. So how it works? Tax trigger monitors mainline. Currently it's mainline, but we can change it to any repository. Detects changes, detects new tags, triggers Pinnacle. Pinnacle, it's a custom utility for generating plans for tax suite. So it creates a plan according to inputs in the required payload configuration, in the targets, hardware targets, software targets, and so on. So it's compiling its own plan and submits to tax suite, which triggers kernel build, and after that triggers testing, which on the turn run tests on the devices. And when testing is finished, we need to collect the results and pass it to perf data pipeline to process the results, analyze them, and make a conclusion: do we have a regression or not, and where we have it. And store it in results database. at this point, we have answers. Do we have regressions or improvements? But to address the issue with consumption of these results, you need to visualize that in some way. And we are using dbt to transform one database to another for more analytical purposes and more analytical queries, and display these results with Percolator, which is a tool for visualization of this data. So you can use Grafana or something like that, but they're not suitable in every case and every scenario. So the companies, and their roles are listed here, but I already mentioned it. Yeah, the thing which is missing, that's on the previous slide, it's intermediate storage for results. Currently it's Squad, but can be any tax API Squad or any other storage. Okay. So the primary workflow looks like this one. So we monitor changes. If we have changes, we schedule build, configure build, and prepare systems under tests, perform tests, gather tests, and analyze them and show the results. Quite straightforward and easy. But the devil in details, and a few details about that. Kernel builds, they can be highly customized, and we can change a lot of parameters, input parameters. It's repository itself, kernel SHA, kernel config options, anything, and toolchain. So any option which we can pass to taxmake, we can change it and get results almost automatically. Systems under tests, currently I'm using Graviton 3 instances, but it can be any supported by TaxSuite, so it's any cloud and any lab device, plus the operating system, base operating system, could be Debian or any other distributions, but we need to satisfy requirements for tests, and it must support Python. It's default, but it's a requirement. Payload configuration. As we have multiple use cases from multiple vendors, we need to configure it for each case. And well, we have standard workflow, standard plan, which contains 8 suits and 44 tests. It's all open source benchmarks and their tests. So payload configuration can be easily configured for your own case or scenario, and with Pinnacle utility, and submitted to TaxSuite. We are relying on micro benchmarks suits, and we can enable any of them, but they should be supported in tests in the executable on ARM64 platform. So how testing actually performed. So preparation, for example, we can prepare a test plan which contains 3 tests, like A, B, C, and each test has its own features or specifics. And for each test, we can provide provision from 1 to X devices. For example, for test A, we provisioned 3 devices. For test B, it's 5, and for test C, it could be 15. And after that, after all the devices provisioned, we can schedule tests, and the tests execution also depends on the test nature. So some tests can be or should be sequentially executed 1 or more times, depends on their characteristics. So it also brings complexity to the entire process. But at the same time, it allows you to do testing more flexible and cover more cases. After that, we collect the results, collect information, and shut down all the machines. So after that, we're doing data warehousing, and we store raw data. It's build and test configurations, operational logs from build systems and test systems, a standard set of tests collections. It's It includes benchmark information and information about the system before and after tests, plus extra information about hardware, because we're dealing with so large variety of machines and their features, hardware features. So we need to collect all of them as well. All of this is stored in results database in structured and cleared form. And after that, when we have the results, we need to perform descriptive statistics calculations and inference statistics if we have to compare. If we have something to compare, so we should have at least two versions, two data sets, baseline and target. Also, we need benchmarks meta information, so information about benchmark itself, test itself, operations which test performs, and historical data, because we cannot ask experts every time. We rely on historical data. So now we have enough data to make any conclusions. So after that, data transformed and enriched with results and the reference data, so we can show it this data to audience. And the results processing stages, they're quite simple. Get data, extract valuable information, process the data, and save the results. But in reality, it's more complicated thing, and a lot of things can be tweaked and tuned for particular case. So this all the stages which data performance pipeline perform does every time. So it's unpacking, getting metadata, measurements, computing stats, creating a hierarchical model for gathered results, performing comparisons, so it's statistical hypothesis testing behind that. And after that, you need to perform analysis for each particular case. And the pipeline does that. So this is a hierarchical model for experiments, for testing itself. So experiments, they combined consist of builds and runs. It mirrors the tax suite plan at a level of run, I suppose. And after that, we have a level of benchmarks, tests, operations, and metrics for each operation. So it's quite a huge model to analyze the data. So processing details, it includes extraction of raw data from MM-tests with MM-tests, but MM-tests themselves, this framework do not provide all required information. They provide only some basic extraction features. So from time to time, I need to implement custom parser to extract more data which needed. Baseline selection, currently it's default way to define baseline. It's take last stable release, which we have in database, again compare to this baseline. But we can choose any baseline if we want. Base stats, it contains all the statistics, so mean, median, and percentiles, and coefficient of variance. We also need to detect outliers to evaluate the overall quality of data, check for normality. Inference stats computation includes confidence interval computations with bootstrapping, because we don't have enough samples every time, so have to apply bootstrapping. And perform statistical tests to get the answer, do we have any difference between baseline and current version, plus additional tests to understand how the effect of the difference. And after we have all this information, we can conclude, do we have improvement, regression, or no change, or the data not reliable, and we need to change the process, change configurations, or check what's going on there, or retest it. Sometimes it's also required. And at this level, we have answered, do we have improvement or regression or no change? But to visualize this data, someone can tell you that you can use MMTest report. It's default feature, but this report's not very consumable. It's if you are doing this on your daily basis, maybe it's clear and useful, but for broader audience, it's not so useful. It's just a bunch of charts and numbers, and some of them not suitable for every case. So I developed the percolator. I cannot show all the screens of this utility, but it's guides you from high level of a device and its configuration to overall kernel state, the state of different subsystems, how many regressions or improvements we detected in particular subsystem, and go deeper and deeper to details and down to particular test run. So from my point of view, this information can be consumed for broader audience and make this system more useful for more people. So the last thing, our findings. So that's analysis report. It contains multiple such records because system does a lot of tests, and this is just one of the sample. Typically, it's more than 100 such records, and for each record you have a conclusion, regression, or improvement. And all the required details are here, and you can take it and analyze what's going on with the system as kernel. We also tried to apply this system to, well, we detected a couple of regressions, and we decided to bisect them using this system. And that was done with two people independently. One followed traditional methods and using some traditional tools, and the other, and I used that system. And we both got almost the same numbers. Well, they differ but a little bit. And we were able to bisect to commit, which caused regression. Even such small numbers, but they are detectable, and we can see regressions from version to version, from large span of versions for a particular platform. So that's what we have right now. System still under development. We need to tune it more and add more features to this to make it to build better pictures and more clear pictures. And that's our plan. So we are going to move percolator to public domain to make this data accessible for broader audience, and cover more regression cases. So if you have regression case which you can describe somehow, please report it. It will be highly useful for ML training and ML detections models. And well, the other options maybe not so important right now. So support more configurations, hardware configurations, software configurations, and implement automated bisection for large regressions, which we can confirm and well, report. So that's, if you have any questions, just join our Slack channel or drop me a message. I will answer. I hope. Thank you.